然后接下来请 Google Cloud Platform 的那个 Sato 开发者为我们带来 Your Data in the World Beyond MapReduce。大哥，中控有看得到画面吗？
没有，你现在那个投影没有，我上面一定没有。
大哥，这样是有的吗？
现在也没有。有了。
好，谢谢。
Okay, let's start my session, which is titled Your Data on the World Map Beyond MapReduce. I'm Kazunori Sato. I'm a developer advocate working at Google Cloud Platform team. I'm working at Tokyo office, and I'm covering the Asian countries such as Taiwan and India, Japan, and Southeast Asia countries. And my job is to support the growth of the Google Cloud developer community in Asia. And also, I'm supporting launching the new products from GCP Google Cloud teams. We call it as GCP, Google Cloud Platform, just like they call it as AWS. So yeah, please remember it's GCP. So when I explain what is GCP and what's the difference between GCP and AWS, I always use the word the data center as a computer. The data center as a computer is the name of the title of the book written by Urs Heltre. Urs Heltre is Senior Vice President of Google, who is responsible for all the Google's infrastructures, like the building the data center, or the building the servers and networks, or the implementing the middlewares such as the MapReduce or Bigtable, everything. The Urs Heltre is the guy who built the Google Cloud, and he used the word the data center as a computer. That means we build the whole data center that works as the single computer, but that has the tens of thousands of servers inside the building. So it's not just the data center building which is hosting the many servers. We designed the whole data center as a huge distributed cluster, single computer, and spread all the workload, like a Google Search workload or Gmail or Google Maps or GCP workload, into these tens of thousands of the computers inside the data center. So that's the largest difference. So I'll be talking about what does it mean. And all the data center we are using inside Google are built by ourselves. Some people say that Google is one of the largest server vendor in the world. because we are not exposing how many servers we are operating, but apparently it's more than the tens, hundreds of thousands of servers, and we are building all the hardwares by ourselves. When you are looking at the job opportunity pages on the Google.coms, you can find we are hiring many hardware designers or LSI designers at Mountain View headquarters. So we built our own servers and also the networks, switches, routers by ourselves. And also, all the softwares or middlewares running on the servers are also developed from scratch by ourselves. You know, the most famous big data solutions, MapReduce, is originally designed and developed for building the world's largest batch processing framework for Google search service. So the researchers such as Jeff Dean or Sanjay in Google invented the MapReduce technologies to build the world's largest batch processing for Google search service in early 2000. And we have published a paper about MapReduce. That paper was the origin of the Apache Hadoop MapReduce and its successors such as Apache Spark or any other open source based big data solution. Google File System is the origin of the HDFS file system. And Bigtable is still the most, the leading NoSQL database we are using for many of the Google services such as the Gmail or Google Maps. If you are using Gmail, your email are stored on Bigtable. This is the largest NoSQL database we are using. So those are the first generation of the Google's infrastructure softwares. And now we have shifted to the second generations, such as Crossus. Crossus is the next generation distributed file system. And Spanner, the AdWords, Google AdWords is now entirely running on the Spanner, which is the successor of Bigtable. And other technologies such as Dremel and Borg. I'll be talking about in detail about Dremel later, and Borg as well. So GCP is all about externalizing the most powerful infrastructure we have at Google Data Center to the external developers. So just like they do in AWS, we provide the many variety of services such as big data solutions, storage services, compute services, networking. I will not discuss detail about those GCP products, but I'll be focusing on what's the difference and especially for the big data, what's the difference between our big data solutions with the other open source based solutions. And now we have the many largest customers accounts for GCP in the world. Actually, 1 year ago, I spent some time in Taiwan to have a serious, long technical discussions with the HCC guy. HCC is one of the largest users in Taiwan and Asia region. So they are now using a huge amount of the computing resource on GCP data center, Google data center. And the other major players, the Snapchat is one of the most successful social photo sharing service in US right now. They are running all the services on GCP, especially on Google App Engine, which is the hosting service. And recently, they have achieved 1 million requests per second record by using Google Compute and Google App Engine. So let's talk about the world beyond MapReduce. What's next after MapReduce? We are using the technologies such as Dremel or Flume. Please note that this is not the Apache Flume. This is totally different thing. We call it the Flume Java. This is a Java-based data pipeline framework. So I'll be discussing about this later. So, and MillWheel, this is maybe the world's largest stream processing, real-time processing framework, mostly for the AdWords. And we are externalizing those technologies to the GCP customers as BigQuery and Cloud Dataflow. So let's talk about BigQuery first. So the origin of BigQuery was the origin of BigQuery started in early 2000. Like it was in the 2006 when we started using the Dremel or BigQuery infrastructure inside our company. So BigQuery has been in production since 2006 in this company. And without BigQuery, well, internally we call it Dremel. Dremel is the internal code name for BigQuery. Without BigQuery, any single Google services cannot be operated in so-called Google speed. We call it as Google speed. Every businesses inside Google should be executed in a very, very fast pace. We call it Google speed. And BigQuery is the basis for all the Google speed businesses in the company. For example, if you go to the YouTube team, they have 1 billion users in the world. Android team has 1 billion devices. Google search team is getting 100 billion search queries every month. And Gmail team has 900 million active users. And all single Google service is producing the tons of the really, really big data, like tens of terabytes of the log data every day. So how do you handle that? Do you have time? Do you think that Googlers have time to start up your MapReduce jobs to scanning all the terabytes of data? Yeah, actually, when I joined Google 4.5 years ago, I was working at the AdWords API team, and I was supporting the one with actually they were the largest AdWords API customer in Japan. And the customer would call me in the morning and about troubleshooting. They would call me and say, what's happening on our ads? The mobile ads targeted for the Tokyo region is not showing on the Google.com, Google COJP. Why is that? In that kind of the troubleshooting case, or whenever your manager or director in Mountain View will be checking you and get the result in a few minutes, I don't have any time to start up my MapReduce jobs. That would take like 4 or 5 hours to scan through all the terabytes of data. No, we are not using MapReduce at Google anymore. We are still using the very little classic MapReduce inside Google, but it's a minority. The majority of big data processing inside Google have shifted into Dremel, BigQuery, or Flume Java, or MillWheel. So let me show demonstrations of how powerful BigQuery can be. So this is the BigQuery the user interface. And actually you can start using this user interface without spending any money. All the Google account have the 1 terabyte free quarter for trying out the sample query with BigQuery. And now I'm trying to execute a very simple SQL-based query on table called wiki10b. Wiki10b is a sample table which has the 10 billion access logs imported from the Wikipedia website for several years. And it has a column named title. It's the title of the Wikipedia content. And I'm trying to aggregate the number of the page views of the Wikipedia content, which has the cloud keyword inside any part of the title by using the regular expression match. If you have any experience on using the regular expression match on the where clause, you know that if you do on the, for example, 1 million rows or maybe 10 million rows, that's going to be a full disk scan. It's a table scan. The regular expression doesn't allow you to build the a database index at all. So that means you need to do the full scan all the times. So if you do these things on the 10 million rows, you would have to wait for maybe a few hours Basically, you are not allowed to do that with the traditional database. But what about BigQuery? Let's do that. So now it's running in the data center inside Google in United States, and you got the result within 7 seconds. The BigQuery actually scans through all these 322 gigabytes of data read from disk drive and get the result back to you in 7 seconds. And please note that there's no caching or no indexing in BigQuery at all. So you got the result here. So this is the power of the BigQuery. Whenever, how much, you don't have to care how much data you have to scan. In Google, we have tens of terabytes of the log data all over the Google services. And nobody cares about the size in Google because we have BigQuery. As long as you're using BigQuery, it can scan the largest data set within tens of seconds. So even if you are handling much larger data sets, such as 100 billion rows, with full scan, table scans, you can get the result within 30 seconds and scan through the 4 terabytes of disk drives and applying 100 billion regular expression and shuffling the hundreds of gigabytes. Why BigQuery can be that fast? If you do the same thing with Hive or Hadoop, you have to wait at least a few hours. The one reason is the column-oriented storage, but I'm kind of skipping this part because this is a very ordinary way. And the other products such as the Drill or Impala or the Presto or the Redshift, they're all using column-oriented storage. That's the same as the technologies we are using. But the largest difference is the parallelism. It's massively parallel. So whenever you execute a single query on BigQuery, that query will be running on the 1,000 to 2,000 servers that has total 5,000 to 10,000 disk drives running in parallel. For every single query, even if you're using a sample-free quarter, your query will be running 5,000 to 10,000 disk drives for every disk drive. So that's the reason why BigQuery can be that fast. And that's the reason why every single business or organization in Google can work in the Google speed. So in Google, we don't care the size of the data anymore. And why you can deploy, you can use the thousands of the servers just for BigQuery. The reason is the word data center as a computer. Because we designed the whole data center as a single computer. So that's the reason why you can run the BigQuery on the tens of these thousands of servers easily. Recently, we have published a paper about Borg last April. Borg is the container technologies we have been using Google for over 10 years. Maybe you didn't know, many of you didn't know that all the Google services, such as Google Search, Gmail, Google Maps, are not running on virtual machines at all. How many people knew that we are not using virtual machines? Or 3 people, yes, that's the normal response. Google are not using virtual machines at all. And Facebook doesn't use the virtual machines at all. If Google and Facebook doesn't use the virtual machines, the majority of the cloud services are not using virtual machines at all. We are all container-based companies. Google, Facebook, and maybe Twitter is also using the Twitter containers. So by having the booming of the container technologies such as Docker, all the companies such as Google and Facebook or Red Hat, IBM, is now suddenly started exporting the container technologies that we have been using inside the company for long years. So Borg is another container technology that has been kept secret for over 10 years, but now we have exporting. Borg is just like the Docker, it's a container technology, so we are using physical server without using any virtual machines. And we are using containers to contain each different services, such as Google Search or Gmail or Google Gmail or GCP services. But the largest difference between Docker and Borg is the scale. Single Borg master is managing 10 to 20,000 machines in a data center. So that you can deploy the things like BigQuery or the Gmail into the tens of thousands of machines by a single click. It's really easy for our engineers to utilize the huge amount of the server resources with very little operation. And I went to visited the Taipei data center, Google's data center in Taiwan. It's in the Taichung area. We have several buildings built from scratch, and I've seen there was I cannot say the exact numbers, but it was at least tens of thousands of servers running inside the Taiwan data center. And every single server in Taiwan data center was running by Borg. So that means whenever the BigQuery team or Gmail team or GCP team want to deploy your single services into tens of servers of machines, you can do that even in Taiwan by using the single command. So that's we call it data center as a computer, and that's something the other cloud vendors are not doing right now. And another interesting technologies we are using for BigQuery is the tree-structured aggregations. Actually, this is derived from the Google search service. If you go to google.com and do a keyword search, then your query will be handled by hundreds of servers in parallel on memory. So that's the reason why Google search can be that fast. And we're using exactly the same network infrastructure and remote procedure call infrastructure to realize the Dremel or BigQuery's massively parallel query. We have 2,000 machines, and each SQL will be split into the 2,000 machines and handled in parallel. And at the top layer, you would get a really high peak traffic, such as several gigabit per second, and you have to have the really thick Ethernet network boundaries at the top layer. Again, this is all designed from hardware-based to support the largest applications such as Google Search or Gmail or Google Maps. We are just reusing that for GCP customers. And there's another interesting technologies for shuffling. I cannot tell details about these technologies because there's no paper about these technologies published at these times. But you can think this as a large shared, distributed shared memory shared with the thousands of machines in a data center. Or I would sometimes use the word data center as a supercomputer to explain these technologies. By using these technologies, BigQuery can do the join 10 billion times 10 billion table join in 30 seconds. Okay, if you do that join with the Hive, you have to wait for tens of minutes or maybe hours. But we can do that within 30 seconds. So how to use BigQuery? Now you have understand what kind of the performance and why what kind of performance BigQuery can provide and why it can be that fast. It's because we are designing data center as a computer. That's all. And how to use that? In last year in Japan, BigQuery had a huge booming for the AWS EC2 users because they got the Flume plugin for BigQuery. Flume is the most popular log collector open source tool, especially used in the Japanese customers and also in the worldwide customers. And in Japan, maybe 80 or 90% of the EC2 users are using the Flume log collector. Flume is F-L-U-E-N-T-D, Fluent D open source tool. And every AWS users are using that. And one core committer has written a plugin for BigQuery for Fluent so that by putting that plugin into the EC2, you can instantly sending all the logs from Nginx or application servers, everything, directly imported into BigQuery in real time. Usually, AWS people would be, storing all the log data into S3, the object cloud object storage, and then importing the log into the Redshift by batch process. So you have to wait 1 day to start querying on the access logs on Redshift. And Redshift is not so cheap. It has a certain price. But what we had last year in Japan, everybody started to switching the log data from sending to this S3 to BigQuery directly, because as a storage, BigQuery is cheaper than S3. Another advantage of using BigQuery is its cost. BigQuery as a storage is cheaper than AWS S3. So what happened in Japan last year was everybody is now storing all the data on BigQuery directly rather than using S3. And then you can execute a query in real time. You don't have to wait 1 day for the batch processing for the Redshift. You can get all the KPIs 1 minute 1 minute after getting all the accessing log imported. And also Google Analytics can import the logs into BigQuery every day automatically, and you can join the analytics logs with the other customer transaction logs. How to visualize the data? You can use the Tableau or BIME or QuickView, that kind of the business intelligence tool integrated with BigQuery. Or if you're a data scientist, you can use R or Pandas or IPython notebooks. All of those tools can execute a BigQuery query from the environment to BigQuery. Google Spreadsheet or the Excel is the most reasonable or maybe cheap way to have a dashboard or visualizations for the BigQuery result. Google Spreadsheet has a Google Apps script that lets you write a JavaScript code to run the BigQuery query and draw a graph or chart based on the result easily. And also, if you have an existing Hadoop code base, you can use BigQuery table as a HDFS. So you can replace the existing HDFS data source with BigQuery table. And let me show you another interesting example of the business intelligence tool. This is a business BI dashboard built by a company called BIME. BIME is the one of the most popular cloud BI tool vendor, and now they're providing the connector for BigQuery. This is the real ERP data imported by some largest retail company in US, and now they have 1.3 billion rows of data imported in BigQuery. And what if your exec or director want to drill down into the revenue in the California region? You can easily do that by using the BIME user interface. And now please notice that all the queries, the data analysis, are done in real time without building any database index at all. Usually, if you want to build this kind of the dashboard or BI tools, you always have to spend tons of money to design the database index for the data warehouse or data mart or data cube. But again, BigQuery doesn't have to build any index at all. So all the queries into the BI tool can be processed in real time without having any index or caching. But still, you can get the result within 10 seconds, maybe 10 to 20 seconds, just like this. So this is, again, the power of the BigQuery or Dremel you can get. Another interesting applications for BigQuery is an IoT. This is a Raspberry Pi box. Raspberry Pi or Raspberry is the very tiny Linux box, you can buy it on Amazon.com at like $30 to $40. It's really cheap. So I bought it for myself, and I bought some sensors, temperature sensors, humidity sensors on it in my weekend time. So this is the Raspberry Pi box I built in weekend, but still this is already the world's largest IoT platform for sensoring the weather data such as humidity or everything. Because I was able to install the Flume, the open source log collector, inside this box to send all the metrics into BigQuery directly. So I didn't build any backend or front end at the server side to receive any data for the Raspberry Pi boxes to the backend. Usually, if you want to build a large-scale IoT platform, you have to spend, like $1 million or several $1 million to hire the expensive server-side people, server-side engineers, to build the front ends to gather all the metrics from the sensors or devices. That has the backend will have to have the fault tolerance and the durability, the replication, everything, the largest difficult cloud design. But BigQuery already has the most scalable front end for importing the data in real time. It can import 1 to 2 million rows per second for each customer project. So I can just buy 1 million devices, 1 million Raspberry Pi box at the store and deploy it on everywhere, every cities in the world. And still I don't have to spend any money for building the world's largest IoT platform. BigQuery has all the capability to import the millions of rows in a second. And you can use the Google spreadsheet for the dashboard like this. This is the pressure record when we had the typhoon hitting on my home. So you can see the drop in the graphs where the typhoon was hitting my home. Again, I spent only like 50 to 100 bucks US dollars to build this thing. 7&i is the holding company for the 7-Eleven convenience store, and they are the largest retail company in Japan. They have been using BigQuery for over 2 years for production. The purpose is they are importing all the customer purchase logs, transaction logs into BigQuery, and also importing the analytics logs into BigQuery, so that what happens, they have the e-commerce website where the customers can buy anything on the website, so that you can know what are the customers who are actually accessing the website recently, and also who has the certain amount of the lifetime value. They have the customers who actually have the purchase history, so that you can get the list of the premium customers who is really likely to make the future purchase. So why not use that list to do the digital marketing or direct mail marketing? So you can just upload the premium customer list to the AdWords retargeting or remarketing list, so that you can optimize your digital marketing. So summary of the BigQuery. BigQuery is blazingly fast. Google cannot do any single business without BigQuery. Google is running on top of BigQuery. It's low cost. It's lower than the S3. It's cheaper than S3. And each query is very cheap. It's fully managed, so you don't have to hire expensive database administrators or the people who are taking care of the Apache Spark or the Zookeeper classes. You can use SQL. So I'm so impressed when I joined Google that even the non-programmers or non-engineers are using BigQuery or Dremel every day. Because BigQuery is all cloud-based and it's really scalable, even if your SQL query is not so efficient, sometimes people execute very inefficient, very bad SQL on BigQuery. But BigQuery doesn't care. And that kind of the bad SQL doesn't affect any performance to the other users. So that is the largest the impact for the IT department. So IT department don't have to care about the SQL quality. That means they can let the end users inside company copy and pasting the long SQL and execute on the BigQuery by themselves. The IT department don't have to care about that. Okay, so I don't have much time to going through the data flows, so I'm just skipping this slide, and maybe I can mention about the most important part. Data flow is something like the Apache Spark, where you can write any Java program code or Python program code to handle the things more than SQL. BigQuery doesn't solve all the problems. It's a SQL, so sometimes you have to write your Java code or Python code to do the most complex things like machine learning or clustering analysis, everything, or ETL, data cleansing. And you can define a so-called pipeline. It's a direct cyclic graph by using Java code. And you can do the MapReduce transforms just like the MapReduce by using the transforms defined in the data flow. For example, you can read the text file, read from the Twitter stream, and extract the tags and counting the tags and sorting the tags to implement the auto-completion services. And the most important feature of the data flow is that it's integrated. It has integrated both batch processing and stream processing. So if you want to do the same things with the stream processing, you can still use exactly the same application's code. Okay. Oh, it's okay. With data flow. So this is the stream processing version of the auto-completion sample code. So all you have to do is changing the input part and output part. Instead of reading data from the cloud storage, you can read the data from the PubSub, which is the real-time event streaming framework, and defining a windows. What's the scope of data you want to process on a stream of data. And all the other application logics can be reused for both batch processing and real-time stream processing. So you don't have to have two different teams on Apache Hadoop MapReduce and Apache Spark Streaming or the Apache Storm. And everything is fully managed and optimized. So all the scaling of the instances or the optimizations or the data pipeline optimizations like this are taken care by the data flow runtimes. And also you have the real-time monitoring UI. Sometimes it's really hard to know what's happening inside the Apache Spark cluster or the Hadoop MapReduce jobs. But by using data flow, you can know it in real time. How much records or each phase is processing, what's the latencies. So it's fully managed, batch and stream processing integrated, and it's really easy to design the pipeline. And if you have interested in those technologies, please go to the cloud.google.com BigQuery or /dataflow. /dataflow is now in beta, and we hope to release it as a GA, your final product, in later this year. Thank you so much.
喂，谢谢Sato桑为我们带来 Google 跟那个 BigQuery 的应用。